In the previous video, we discussed the principles of standard deviation, how that is related to the concept of safety inventory, and how that is related to the concept of risk pooling. In this video, I'm going to explain how this is achieved under different dimensions. We achieve risk pooling in the dimension of the geographical location. We can achieve risk pooling in the dimension of the product, and we can also achieve risk pooling in the dimension of time. So we're going to discuss this in detail, and we're going to explain how that works. They receive different names in case of in the case of time, but very diverse number of companies are using this to remain competitive in the marketplace. So let's start. Very good. Let's consider our first case, which is where the demand depends on, or we're going to be pulling the risk based on geographical locations. Consider two different regions that are supplied by warehouse number 1, warehouse number 2, and each one is dedicated to its particular region. Then you have the alternative to concentrate these, eliminate one of them, and concentrate the operations based on only one of these. It could be one or the other, or it could be a different location, and we're going to discuss that maybe in some other video. But let's assume that that all the demand that it's currently served by this region number 2 is going to be also served directly from the first warehouse, and therefore we don't need this warehouse anymore. So we're consolidating the demand for this region into this warehouse. If originally the warehouse 1 had an average demand of 75 and a standard deviation of 20 in the demand, and warehouse number 2 had a an average demand of 102 and a standard deviation also of 20. Now if the customer service expected was 84.13%, then you needed 20 and 20. But now with the consolidated effort, the expected shipments of both regions are now 180, and the standard deviation for that particular warehouse is now 28.28. So that's how we can solve these in terms of the geographical location. In terms of the product, works in a similar way. Let's say that you have a part to manufacture, say, a bicycle. Many of the parts could be used in a similar way to produce more than one finished product. So the demand for the product 1, if it was separate for the finished product 1, it's 75 and the standard deviation is 20, and the demand for the second product is 105 and the standard deviation is 20. Now if you use the same part, say for instance the chain, instead of having specialized chains or the gears or the brakes, any one of these parts that could be different. Now if we use a common part for both finished products into a single common inventory, now this common inventory, this common demand also becomes total demand of 180, a standard deviation of 28, and that affects the uncertainty about which parts to use, because now it's clear we're going to use the same common part, and not only that, we are in need of fewer number of parts stored in our warehouse to make sure that that works. Finally, in terms of time, it's a very well-known case that when you buy a product from this company, the United Colors of Benetton, the shirts or sweaters that you can buy, these they manufacture these not in a particular color, but they manufacture them just in a plain color that it's kind of a cream color. And then what they do is, depending on which colors are being successful, they produce, or they tint this. Once it's already been made, they tint it to different colors, so they can choose to go with red or blue or green, for instance, white, etc. But not only that, they can then later on, or if the combination of colors that are more frequently buy, for instance, red and blue, or blue and green, or all the other colors that they use, blue and green, now they can have the product in the colors that the customer wants. All they have to do is originally just produce them in no color at all, and be flexible at the very end to change it to the color that they need. This is what is called product differentiation postponement. Product differentiation postponement. And several companies use this strategy. Another company that famously used this strategy is Hewlett Packard in the manufacture of their printers. The printers are consumed worldwide, but not all the power coming out of the wall is designed the same way everywhere. So the way to deal with this is they manufacture the printer. They don't know where it's going to go. At the very end, once they have an order, they open the box and insert the proper power supply that will make it work, and then they ship them. So this is a very unique set of operations. All of them are designed to achieve reducing the effect of uncertainty in the demand. And as I said, we can do it by geography, as explained in this example, by product or product lines, product components, or this is a combination of product components and also time, because it is at the very end that the product is differentiated. I hope this is clear, and you see the relevance of respooling in supply chain. There's another concept regarding, or another way to use the concept of respooling, and that is, for instance, in transportation. In transportation, you may have the need to transport product from location 1 to location 2. But there may be other firms that are also interested in, that are nearby you, in delivering that product somewhere else. So what the most modern companies are doing now is they are coordinating shipments for products that are not competing. For instance, tires could be shipped with disposable diapers. Now, these two products are not competing. These two products are not going to contaminate each other, and these two products can go on the same truck, And whereas if there is a larger amount of diapers needed or a larger amount of tires needed, or any combination of those, the same effect of cancellation of the two demands would happen for the transportation. So what happens now is that, say you have company for tires and the company for diapers are all serving the same remote market. What they could do now is they can negotiate with the transporter, with the freighter company, because now they can ask, well, we're gonna for sure gonna have this amount of volume. You will not run on risks. If it's either one or the other, that you're going to carry full load trucks from our origin to the destination. And that allows for negotiation based on volume and safety in the amount of business, and that reduces the cost. So that's another important way of reducing the risk in supply chains.